We're going to be opening this whole space up with this giant beam. So I started by planing just like a 16th off of these LVLs. They needed to be inserted within the I-beams. And this is the reason why I'm chamfering these two edges. The eyes obviously get that corner bead on the weld, so this is going to make it so it's a snug fit. Next, I'm going to use my grinder to clean up the edges and so that I can do a test fit. It worked, so we can keep moving. This beam is like 20 feet long, so it was pretty heavy. Can't forget to wear protection, of course. And then I'm going to go ahead and clean out this metal everywhere on this I-beam so that it's a nice cleaner fit for all the wood that needs to go in between here. This was drawn out by an engineer, guys, so if you have qualms of how this is done, go talk to him. Don't come at me. We made a couple of short sawhorses to put these on, and it helped a lot. Now, I didn't need the extra chamfers here. I messed up, so I put it on the outside so that structurally it would still be a snug fit against the metal. There's going to be two LVL beams here on either side of this I-beam, and that's because these I-beams only came 20 or 40 feet. So instead of having a whole bunch of waste, because this is like a 27-foot span, the engineer drew it like this. To sandwich 4 LVLs inside of the I-beam, 2 on either side, and then bolt them through together. The LVLs will extend past the I-beam 3 feet on one end and 4 foot on the other, roughly that. As you saw, we made a bunch of holes, and that's for carriage bolts. We're going to be bolting everything together so that this essentially becomes one giant piece, one giant beam. This one was quite the tight fit, as you can see. Eventually we had to get the sledge out here to do this. Not on this piece though. This one went alright. Once we got it perfectly lined up, I will temporarily screw the board, flip the beam back over, and then use the same holes as guide to finish all the way through. I'll then use this plywood template to recess the heads of the bolts a little bit. This was also approved by the engineer, and that's because we got to insert this beam into that slot, and if we didn't do this, it would be a nightmare. The engineer agreed that there would be enough meat on the wood if we did that, so it was not an issue. The holes came out to be 3/4 on one end and about 1/4 on the other side. We'll repeat the process for the whole rest of the beam. A whole bunch of carriage bolts, as you can see here. We'll smack them in, put the nuts on them, tighten them a little bit, cut it, tighten it all the way, and then cut it again. And there, right there, ladies and gentlemen, is a very big chunk of beam. It was just heavy. You see that I used some timber locks here on the other end, and they're a little long, so I'll just smash it in. It's rough framing, who cares? Now, to install the beam, we first need to install some shoring walls on either side to hold the weight of the room above. The bottom plates here are 2x10s, but we didn't need to do that. It's just what we had laying around. Now that that's supported, we can demo this part. It's going to make a big difference once this stuff comes out. Now we got to pop our lines to see where our beam is going to go and start doing the demo. First step is to take out all of these blocks. And now we're going to make a giant cut here so the beam can go inside of it. I go up as far as I can with a circular saw and then use that cut as a guide with the Sawzall. I double checked every single cut with a level. If it was not plumb, we cleaned it up with the oscillating tool because I want to make sure this goes in one try. I don't want to have to pull this thing back out because it's not right. We rented this genie lift to pull the beam up or push the beam up, and we went halfway and started adding like safety measures here, basically 2x10s just in case something went wrong. This thing wouldn't come smashing down all the way. I also needed to switch the fork on the genie lift to go above the track, so that's also worked for that reason. Now look at my face. I look so calm right now. And then I start struggling because it wasn't necessarily easy to rack this thing up like that. Once you got right before the input here, we put another safety up, transferred it up basically, and then started slamming it so that it was in the right place. The sledgehammer is what it took to do this. You'll see later I'll try to hit it with the hammer, my regular hammer, and it doesn't do anything. Right. So switch back to the big boy hammer, the sledge, and get this thing to go in there. I put my stepfather on the gear here so that I could slam it as it needed, and then eventually it goes in. And actually it went in a lot easier than I thought it would, and we got it. Now the beam is in. It's still supported by the genie lift, but I want to make sure to push it up more I need to, so we're gonna get a jack and make a little T-brace so we can do so. Once it's jacked up, I will build my supports on either side. He asked us to use some 4x4s, and this goes directly over a beam that's in the middle underneath the floor. Now the ceiling joists were not lining up with the beam, so we had to adjust each one individually before we nailed it. But once we got it, you can see that the room held, and yes, it looks a lot better, at least in my opinion. There was a 1/4 inch of sag, which was what was allotted by the engineer, and that's what the supports look like.